Download this code from codegive.com, link in the description below. A deep dive into Python's urllib.request and URLError, handling network issues gracefully. This tutorial explores Python's urllib.request module, focusing on how to handle potential network errors using the URLError exception. We'll dissect various scenarios, provide detailed explanations, and illustrate best practices with comprehensive code examples. We won't directly reference ProgramCreek.com, as their content is not consistently available and might change, but the principles demonstrated here apply universally. 1. Understanding urllib.request and its purpose. The urllib.request module is Python's go-to library for opening and retrieving URLs. It provides functions for fetching data from various sources, including web servers, files, and other network resources. It builds upon lower-level networking functionalities, making it easier to work with HTTP, HTTPS, FTP, and other protocols. Key functions include *urlopen, the primary function for opening a URL and reading its content. *request, allows creating customized HTTP requests, example specifying headers, methods. *HTTP error, URLError, exception classes to handle network-related problems. 2. The URLError exception, the heart of error handling. When something goes wrong during a network request, example the server is down, there's a DNS resolution failure, or the connection times out, urllib.request raises a URLError. This exception is a broad category that encapsulates various network-related problems. It often has a reason attribute providing further details about the error. A URLError is often a subclass of urllib, operating system error. Understanding the underlying error is crucial for effective error handling. 3. Common scenarios and how to handle them. Let's illustrate error handling with different scenarios using code examples. Scenario 1, server not found, HTTP 404. This example attempts to access a non-existent page. The HTTP error exception, a subclass of URLError, will be raised, providing the HTTP status code, 404, and a description. The except block specifically handles HTTP error first for refined control. Scenario 2, DNS resolution failure. If the DNS server cannot resolve the host name, a URLError is raised. The error message might indicate a name or service not known error. Scenario 3, connection timeout. This example sets a short timeout. If the server takes longer than 1 second to respond, a URLError will be raised, often with socket.timeout as the reason. The code checks for this specific reason. Scenario 4, handling multiple exception types *. This example shows how to handle a specific SSL.SSL error, a subclass of URLError, that can occur with HTTPS connections if there's an issue with the SSL certificate. 4. Best practices for error handling. *specific exceptions first. * catch more specific exceptions, like HTTP error, before more general ones, URLError, exception. Informative error messages. Provide detailed error messages including the type of error, its cause, and potentially the URL. Retry mechanisms, advanced for transient errors, like timeouts. Consider implementing retry logic with exponential backoff to give the network time to recover. Logging. Use Python's logging module to record error details for debugging and monitoring. 5. Conclusion. Effective error handling is essential for robust network applications. By understanding the URLError exception and its subclasses, and by employing best practices, you can create Python programs that gracefully handle network issues, providing a better user experience and facilitating easier debugging. Remember to always test your error handling in various network conditions. Replace placeholder URLs in the examples with actual URLs to test. Be mindful of potential security implications when handling sensitive data and using URLs from untrusted sources.